Absolute value signs in equations and inequalities. How can we get rid of an absolute value sign in an equation or inequality so that we can solve it? First, we will need to define absolute value algebraically and just not use the grade school definition that states that everything in the absolute value sign comes out positive. The algebraic definition states the absolute value of x is equal to two things. It's equal to x if x is greater than or equal to 0, in other words, x is positive. But the absolute value of x is equal to a negative x when x is less than 0 or x is negative. Now this definition, especially the second part, is a little troubling because it looks like we're saying the absolute value of x is equal to a negative x. But that really isn't what we're saying, and we'll see that in an example below. Note, the absolute value of x is equal to either x or negative x, depending on whether x is positive or negative. So we have two cases when we're dealing with an absolute value sign. Does this definition fulfill the grade school definition? In other words, that whatever we have in there will come out positive. Yes, it does, as can be seen in the following two examples. Example 1. Let x equal 5. Then by the algebraic definition, we should use the top result since 5 is greater than 0. So we'll put a 5 right where we see an x. So that would give us the absolute value of 5 is equal to 5. Well, that's what we learned in grade school. It worked. Example 2. Let x equal a negative 7. Then by the algebraic definition, we should use the bottom result since a negative 7 is less than 0. So the absolute value is equal to a negative x. Now putting a negative 7 wherever we see x, we get that the absolute value of a negative 7 is equal to a negative 7, and therefore we get 7. It worked also. So this definition is a good one. It does cause anything that's in place of x to come out positive. We will use the algebraic definition to solve equations and inequalities. Equations with absolute values. So we're going to take the absolute value of 2x minus 1 plus 3 is equal to 8. To get rid of the absolute value sign, we must consider the two cases, where 2x minus 1 is greater than 0 and where 2x minus 1 is less than 0. So these are the two cases that come from the definition. The thing inside is either positive or greater than 0, or the thing inside is negative or less than 0. So in each one, we're going to first deal with case 1 where 2x minus 1 is greater than 0, and then we'll deal with case 2 where 2x minus 1 is less than 0. So if it's greater than 0, then we can just drop the absolute value signs because whatever's inside is positive, therefore it just comes out positive. So now we have 2x minus 1 plus 3 equals 8. Now what do? We collect like terms, so we get 2x plus 2 equals 8. Then what do? Subtract 2 from both sides. So now we get 2x equals 6. And then to get the x by itself, we divide both sides by 2. X equals 3. So x equals 3 is one of the solutions. Now we go to case 2. Since the inside thing is negative, we have to use the second part of our definition and say we want the negative of whatever that is. That would make that positive. So now we have a negative, the quantity 2x minus 1 plus 3 equals 8. So what do we do now? We distribute the negatives, so we get a negative 2x plus 1 plus 3 equals 8. Collecting like terms, so we get a negative 2x plus 4 equals 8. Now subtracting 4 from both sides, we get a negative 2x equals 8. Now dividing both sides by a negative 2, we get x equals a negative 2. So we have two solutions, x equals 3 or x equals a negative 2. They both will solve the original. And so we'll check the x equals 3. So we have 2 times, in parentheses, wherever the x is, minus 1. The absolute value of that plus 3 must equal 8. So let's see, 2 times 3 is 6, minus 1 is 5. So we have the absolute value of 5 plus 3 equals 8. And that would be 8 equals 8. Now checking the x equals a negative 2. Once again, in place where the x is, you put parentheses, substitute a negative 2 there. So now we collect like terms on the inside of the absolute value, and it turns out to be a negative 5. So we have the absolute value of a negative 5 plus 3 is equal to 8. And when you simplify that, you get 8 equals 8. So both cases work, so there's two solutions to this absolute value problem. Since 3 and a negative 2 both check out, this equation has two solutions. 6. Inequalities with absolute values. Although it is not necessary, it is best to not apply the definition of absolute value to the problem until it is by itself. So we will get rid of the 2 and the 7 first. How can we get rid of the 7? We can add 7 to both sides. So then we're going to get 2 times the absolute value of 3x plus 2 is less than 10. Now we need to get rid of the 2, so what do we need to do? That's right, divide both sides by 2. So we're going to get the absolute value of 3x plus 2 is less than 5. Now since we have the absolute values by themselves, we can apply our definition to our two cases. Case 1, we're going to consider is 3x plus 2 is greater than 0. In case 2, 3x plus 2 is less than 0. Now can you tell me what's going to happen once we try to do both of these when we're using that definition? Okay, now let's see what does happen. Okay, by applying the definition to both cases, in the first one, since it's positive, the absolute value doesn't affect a positive number. But in case 2, where we're considering the inside to be negative, then we have to put a negative outside, so it will be a negative will be a positive. So now we have two inequalities that don't have absolute value signs anymore. So now we can just solve them like we know how to solve inequality problems. So one on the left, subtract 2 from both sides. Now we have 3x is less than 3. Divide both sides by 3. And x is less than 1. We don't flip the sign because we didn't divide by a negative number. Now in case 2, we first distribute the negative. We get a negative 3x minus 2 is less than 5. Then we add 2 to both sides. We get a negative 3x is less than 7. And then we got to get rid of the negative 3. So we divide both sides by a negative 3. And x is greater than a negative 7/3. We had to flip the sign because here we did divide by a negative number. So we have two solutions, in fact more than two. So we look to see if we have an interval here. It's got to be less than 1 and greater than a negative 7/3. So we can express this algebraically as a negative 7/3 is less than x is less than 1. Or in interval notation, parentheses, minus 2 1/3, comma, 1, parentheses. Now the negative 2 1/3 is really a negative 7/3. I just wrote it the other way, although algebraically it's better to leave it as a negative 7/3. But it does give us a better relative size, how big 7/3 is. So now graphically we put on our number line a negative 7/3 and 1, and then it would be not those two dots, so they're hollow circles, and then we would shade in the middle because anything in the middle would work. So it is best to check a point in the answer. I will check 0 just because it's easy to do, and it does fall between a negative 7/3 and 1. So if we put in 0 in our original equation, we get 2 times the absolute value of 3 times 0 plus 2 minus 7 is less than 3. Evaluating the thing in the absolute value, we end up with 2 in there. So 2 times the absolute value of 2 minus 7 is less than 3. And then we evaluate the left-hand side, and we see it turns out to be a negative 3, and a negative 3 is less than 3. So it does check.